Okay, we started reviewing for exam 4. Let's go through these review problems. The first type of questions, just solve using square root property. Let's see the first one, 8. And we recognize this is a perfect square. Right, so this one can be written as x plus 5 squared equals to 24. So we have a square on the left-hand side, so which means we can square root both sides. So we square root both sides. When we square root, we get a plus, minus 2 values. Because a negative number, when we square it, we get a positive. So once we square root, the left-hand side becomes square and square root cancel each other. We have x plus 5 equals to plus minus 24. Remember, 24 can be square root of 24 can be simplified. Right? Square root 4 is 2. So we get 2 radical 6. So that as 2 radical 6. Plus or minus, I'm going to add. So this is square root of 6. But with positive and negative 2 values. We want to solve for x. That means we want to move positive 5 to the other side, becomes negative. So we write the answer as x equals to negative 5 plus minus square root of 2 square root of 6. So yes, I need to switch between my pencil and typing. So I need to go to the icons to do this. Okay, so the solution is x equals to negative 5 plus 2 radical 6 and negative 5 minus 2 radical 6. Often for shorthand, we can write as negative 5 plus minus 2 radical 6. So we like to write the rational numbers front. Negative 5 is rational, right? We like to write the irrational numbers second, just by convention. Now let's see B. B, we already have a square on the left-hand side, so it's a square root. So when we square root, we got the positive and negative 2 values. Right? As we do this, we have x minus 7 equals to plus minus 9. Square root of 21 is 9. But we got plus minus 2 values. So then we move negative 7 to the other side, become positive 7. So I have 7 plus 9, this is 16. 7 minus 9, which is negative 2. So we have 2 rational solutions. Let's see C. C, we want to move negative 45 to the other side. Then we have a square on the left-hand side. We have 5x squared equals to 45. Now we have 5 in front of x squared. So we want to get rid of this 5. How do we get rid of? We divide it by 5 on both sides. Right? Basically, we divide on both sides. Then we get x squared equals to 45 divided by 5. That's 9. Once we have square by itself, we want to square root. Square root give us plus or minus 2 values. And then we know square root of 9. Square root of 9 is 3. So x equals to 3 and negative 3. Also 2 rational solutions. Now let's see D. We have a perfect square on the left-hand side already. So we just square root. Square root both sides, we get a positive, negative 2 values. Now we get an irrational number, right? Square root of 3 is irrational. Square root cancel each other. So we have 5x plus 2 equals 2 plus minus square root of 3. Same thing, we're gonna move 2 to the other side, becomes negative. Then we want to divide it by 5, right? So let's do one other step. So we have negative 2 plus minus square root of 3 plus minus square root of 3. Then we need to divide by 5. We want to divide by 5 on both sides. So our answer is x equals to negative 2 plus minus square root of 3 divided by 5. Two irrational solutions. Okay, I have to clear this, go to next. Next question, we're asked to do completing squares. So we want to complete the square. So how do we complete a square? So let's move this 16 to the other side. Let's rewrite it. The x squared minus 10x equals to negative 16. Okay. Now we look at the number before x, which is a negative 10. For negative 10, we want to use negative 10 divided by 2. So we do negative 10 divided by 2 to get negative 5. How do we use this negative 5? Negative 5 square. Let's put it one more time. So we want to square. We want to square this number. Negative 5. Basically, we want to. Why it doesn't? Okay, we'll go here. Negative 5 squared equals to 25. So basically, we want to add and subtract 25 on both sides. We add 25 on the left-hand side. We add, oh, this is negative 16. We add 25 on the right-hand side. When we do this, you see the left-hand side become a perfect square. Becomes x minus 5 squared. Because the negative 10x, the middle term is negative, equals to 25 minus 16, that's 9. So now we have, you see, this, we have completed a square. What is the trick? The trick is just adding a number to make a square. Now we add on both sides. Now we have a perfect square on the left-hand side. It's a square root, same as what we did in the question 1. It's a square root both sides. When we square root, we get plus minus 2 values. So now we get x minus 5 equals to plus minus 3. Square root of 9 is 3. But we get a plus minus 2 values. Now we move negative 5 to the other side. Become positive. So x equals to 5 plus 3, which gives us 8. 5 minus 3, which gives us 2. So I have two rational solutions, 8 and 2. B, we see 1/3, 1/3. So what do? We want to multiply by 3, right? We want to multiply, so we have 3 terms on the left-hand side, 1 term which is 0 on the right-hand side. We want to multiply every term by 3. By doing that, we get a 3x squared plus 4x minus 1, or 0 times 3 is still 0. So the equation becomes 3x squared plus 4x minus 1 equals 0. We want to, oh, you know what? We don't want to do this. No, sorry, we don't want to do this. Let me take back. Because our goal is to complete square, right? Our goal is this. So let me take it back. Let me erase all this. Our goal, well, let's remember our goal. Our goal for this question is to complete the square. So what do? We do the same thing. We move negative 1/3 to the other side, become positive 1/3. So no more negative 1/3 on this side. We won't have two terms here. Then we take the number before x, the coefficient of x, we divide by 2. So we have 3, we have a 4 divided by 3. Dividing by 2 is the same as multiplying by half. Then we see this cancels this. So that becomes 2/3. How do we use this number we found? We're going to square it. We're going to square this. Square this, we get a 4/9. Okay, we add 4/9 on the left-hand side. We add 4/9 on the right-hand side. Now we have made the left-hand side a perfect square. The square is x plus 2/3. That's the number we figured out, 2/3, which is dividing the number before x by 2. Square equals to 1/3 plus 4/9. So how do we plus those two fractions? 1 times 9, that's 9. 3 times 4, that's 12. So we're going to add those two numbers to be the numerator of the fraction. So 9 plus 12, which is 21. And the denominator is we multiply those two numbers. 3 times 9, 27. And we see this one can be simplified, right? 21/27. We divide by 3, we get a 7/9. Okay, now we're ready to square root both sides. Because we have perfect square on the left-hand side, we square root both sides. Again, when we square root, we get a plus minus 2 values. Okay. Get a plus minus 2 values. So let me write this. So we have x plus 2/3 equals to this number. This number can be simplified. Square root of 1/9 is the square root of 1/3. So that becomes square root of 7 divided by 3. Same thing, we're going to move 2/3 to the other side, becomes negative. Right? So x equals to negative 2/3 plus minus, over two values, one is plus, one is minus, square root of 7 divided by 3. Okay, we have two irrational solutions for B, which is we have to deal with the fractions. Okay, let me erase this mess. Let's go to C. Remember, this question is completing squares. Okay. When we're completing squares, we want to make sure the number before x squared is 1. So in this case, in C, we have 2x squared. So what do? We're going to divide everybody by 2. Because we have equation, when we divide everyone by 2, that's fine. I'm going to type, okay. It's too hard to use my fingers to write. So 2x squared divided by 2, have x squared. Plus 5 divided by 2, this is 5/2. 5/2 of x. Then minus 3/2. Well, remember we want to move negative 3 to the other side, become positive 3 on the other side. So 3/2 on the other side. Okay, now we want to completing squares, which means we take the number before x, which is 5/2. We divide it by 2, it becomes 5/4. 5/4 square equals to 25/16. So we want to add this number on both sides. We want to add 25/16 to the left-hand side and to the right-hand side. When we do that, we make the left-hand side perfect square. X plus 5/4 squared equals to 3/2 plus 25/16. How do we add those two numbers? 3/2, we need common denominator of 16. So we multiply by 8/8. Right? So 3 times 8, that's 24. 24 plus 25, that's 49. Then the common denominator is 16. Now we're ready to square root because we have a perfect square on the left-hand side. Square root, left-hand side, square root, right-hand side, we get a plus, minus, two values. So we move the x plus 5/4 equals to plus minus 7/4. Right? So move positive 5/4 to the other side, it becomes negative. So I have negative 5/4. Plus and minus, I'm writing, tapping this way. And the 7 square root of 49 is 7. Square root of 1/16 is square root quarter. So that's our answer. We have two irrational solutions. We have two rational solutions. So how do we simplify these two solutions? So x equals -5, but have a common denominator of 4. So -5 plus -7, that's -12. -12 divided by 4, we get -3. So this is one solution. Another solution is -5 minus, no, -5 plus, -5 plus 7/4, which is a 2/4, which is 1/2. So get two rational solutions, -3.5 for C. D is very similar. We want to divide everybody by 5. Divided by 5, we get a 1. Divided by 5, we get a 4. Divided by 5, we get a 2. So then we want to move this 2 to the other side, it becomes -2. So the left-hand side, we have x squared minus 2x, right, equals -2. So we want to plus 1 on both sides. Because -2 divided by 2, that's 1. -1 squared is 1. So we're plus 1 on both sides. Then what do we get? We get x minus 1 squared equals to -1. Right? -1. This one, we won't have real solutions. So since we have a square on left-hand side, we're ready to square root. So square root, we get a positive, negative two values. So we have x minus 1 equals to plus and minus of I, right? Square root of -1, just I. Then we move -1 to the other side. We get a 1 plus I as a solution and 1 minus I as a solution. Or you can write as x equals to 1 plus or minus I. So two complex solutions, right? Or two complex solutions for D. Okay, it's this. Three, solving by quadratic formula. Let's review, remember quadratic formula. We want to solve by quadratic formula. Quadratic formula is x equals to negative b plus a minus square root of b squared minus 4ac. Then divided by 2a. So we just have to identify a, b, c values. A is a number before x squared. B is a number before x. C is a constant. Then we just plug in, right? So let's plug in. Let's find b squared minus 4ac first. So have b squared, which is 4 squared, which is 16, minus 4 times a times c, which is 4 times a times 2. 4 times 2 is 8. 8 times 1, still 8. 16 minus 8, that's 8. So the discriminant is 8. Then negative b is negative 4, plus or minus 2 values. Then all divided by 2a. Well, a is 2, so all divided by 4. All divided by 4. Oh, hold on a second. I read 8 here. Square root of 8, right? Square root of 8. Right. So what do I get? So this is my value for x. X equals to this. Negative 4 divided by 4, I get negative 1. Then plus minus 2 values. Remember, square root of 8 can be simplified as 2 radical 2. So that simplifies to be radical 2 divided by 2. Right? 2 radical 2 divided by 4 is radical 2 divided by 2. So A have 2 values, irrational solutions. Negative 1 plus square root 2 over 2. Negative 1 minus square root 2 over 2. Okay. B, A is 6. B is 5. C is 4. Well, let's plug in. Let's find the discriminant first. Discriminant is b squared, which is 25. Let me type. Too difficult to use my fingers to write. Sorry. So let's find the discriminant first, which is 25, 5 squared, minus 4ac, 4 times 6, 24. Then 24 times 4, 24 times negative 4 becomes positive number, right? Becomes plus. So 24 times 4, 4 times 4, 16, 2 times 4, 8, so 90, 96. 96 plus 25, 5 plus 6, 11, then, so 121. Oh, 121 is a beautiful number. 121 is 11 squared. Right. So the discriminant is 11. So discriminant is 11. We write as negative b. B is 5 plus a minus 11. Then all divided by 2a. A is 6. 2 times 6, 12. Get 2 rational solutions. Right? So if it's negative 5 plus 11, we get a 6. 6 divided by 12, we get a half. And of course, this is our solution for x. Let's start with x equals 2. Then negative 5 minus 11, that's negative 16. Negative 16 divided by 12 can be simplified. That's negative 4 over 3. So we get 2 rational solutions. What does this mean? This means this original one, if we have rational solutions, that means the original equation can be factored. So that means this one can be factored as x squared. Let me see, negative 4 over 3, yes, which is 2x plus 3. No, 2x plus 3. No, 2x plus 1. 2x plus 1, because I have half, minus 1. 2x minus 1, because I have half as a solution. 2x minus 1. And 3x plus 4. 3x plus 4, because I have negative 4 over 3 as a solution, equals to 0. Okay, but 3 wants us to use to apply quadratic formula. So that means, right, irrational solutions means the equation can be factored, put in a factored form. Okay, let's see C. C, A is 1, B is negative 6, C is 25. Again, let's do the discriminant first. Discriminant is b squared, which is a negative 6 squared, which is 36. Then minus 4 times A is 1, so that's 4. Then 4 times C is 25, which is 100. Well, 36 minus 100, that's negative 64. Negative 64. So the discriminant is negative. So square root of negative 64 is AI, right? So the discriminant equals to b squared minus 4ac equals to negative 64. Okay, so that's our discriminant. Remember, yeah, our discriminant, we need to, so this is our discriminant. We need a square root. So we need a square root of negative 64. And that's plus minus AI, imaginary number, right? So then we have negative b, which is a 6, plus or minus the discriminant. Then all divided by 2, 8. A is 1, so it's all divided by 2. So what do we get? We get x equals to 6 divided by 2, that's 3. That's a rational part, plus or minus. Our discriminant is AI divided by 2, which is 4i. So we have two complex solutions. Right? One is 3 plus 4i. One is 3 minus 4i. Now let's see D. A is 5, B is 1, C, we have to move negative 7 to the other side. It becomes plus 7. So C is positive 7, okay? It's not a negative 7. So then we do the calculations again. Let's find the discriminant first. B is 1. So it's 1 minus 4 times A. A is 5. 4 times 5 is 20. 4 times 5 times 7. Okay. So which equals 1 minus 4 times 5, 20. 20 times 7, 140. 1 minus 40 equals 139. 139, I think is 13. No, 169 is 13 squared. So 139. Right. Then we have a square root to get a discriminant. So we square root this negative. Because 1 minus 140, right, that's negative. Complex solutions again. So we need to put this square root. So that means x equals to negative b, which is negative. Oh, what am I doing? I think I made mistakes. What's 1? No, this is totally wrong. Okay, let's start it from the beginning for D. This is totally wrong. Because x squared, because A is 1, right? B is 5. A is a number before x squared. B is a number before x. C is a constant. So let's recalculate. So b squared, which is 5 squared, which is 25, then minus 4ac. 1 is a is 1, so 4 times 1 is 1. 4 times 1 is 4. Then 4 times 7, which is 28. So we get a negative 3. Then when we square root, yes, we still get complex numbers as a solution. When we square root, so this equals to plus minus square root of 3i. Right. Then now let's put negative b in it. So our x equals to negative b, which is negative 5, plus minus square root of 3i, square root square root of 3i, then divided by 2a. A is just 1, so just divided by 2. So the real part, so it's a complex. We have two complex solutions. The real part is negative 5 over 2. The imaginary part is square root of 3 over 2i. Then, of course, with two values. Negative 5 plus square root of 3i divided by 2, and negative 5 minus square root of 3i divided by 2. So you see, irrational solutions and the complex solutions come in pairs that conjugates. One is plus, one is minus. All right. So let me take a break.